Hi, welcome to week 1, lecture 3, part 2 of 2. I should actually correct that here. Today in this lesson we're going to cover section 1.6, where we talk about logical consistency, truth, falsity, and equivalence. Before we begin to talk about these concepts, we have to introduce some new notation, and this has to do with set notation. So sets are collections of objects, and when we designate a set, we use these symbols, these curly braces. So we use this left curly brace to signify the beginning of the set, and the right curly brace to signify the end. So if you have three objects like a ball, and a watch, then you might say we have a watch and a ball, a set, and the set contains a watch and a ball. And this won't matter for now, but it's curious to note that sets are not ordered. So this set is equal to the set that contains the ball and the watch. So these two are exactly the same. Do it like that. So they're the same. There really is only one set. There's just two different ways of representing it. Okay, so up to now we've presented our arguments in standard form, but we can also collect sentences into sets. And so the way we do this is by using the new set notation that we have. So for example, we might have, so we can do sets of sentences. And here's an example. You might have John is tall, Mary is blonde, and Sally is a great tennis player. So here what we're doing is we're collecting, we have a set of sentences, and there's three sentences. Okay, so why is this important, or why do we want to use this? Well, there's certain properties of sets of sentences that we are interested in logic. And one of the first properties we're interested in is called consistency. So we can say, we'll give this as a definition, and this is a property, notice, of sets of sentences, not a sentence itself, but a set of sentences. So we say a set of sentences is consistent if and only if excuse me, it is not possible, if it is possible, if it is possible for all the sentences in the set to be true. And so let's just give an example of this. Consider the set of sentences, Obama is a Democrat. Romney is a Republican. Bert is a Canadian, which is in fact true. So this set of sentences, Obama is a Democrat, Romney is a Republican, and Bert is a Canadian, this is consistent. Why? Because they can all be true at the same time. Remember, so it's this set of sentences is consistent because all the sentences can be true. And we can also define the opposite of this. So where we have consistency, we can also talk about inconsistency. So a set of sentences being inconsistent. So by definition, we'll say that a set of sentences is inconsistent if and only if it is not consistent. And good. And once in a while, to be clear, we should actually say logically consistent and inconsistent. But for right now, that won't matter. We'll bring that up in a little bit. So let's have an example of an inconsistent set. Only one candidate, if I could spell right here, candidate can win the next presidential election. Obama will win the next election, and Romney will win the next election. This set is inconsistent. Why? Because not all of the sentences can be true. So this set of sentences, again, is inconsistent, and the reason why is because not all of the sentences in the set can be true at the same time. So this set of sentences, so I'm only capitalizing that to highlight the fact that it's a set of sentences that we're talking about. That this consistency is a property of the set of sentences. So the set of sentences is inconsistent because not all of the sentences in this set can be true. So one way to come up with a consistent set of sentences is to actually just remove one of those sentences. So if we were to remove the Obama will win the next election, then we would have a consistent set, although that would be a different set of sentences. Okay, so one of the things that's important to remember here is that logic doesn't actually help us figure out which sentences are true and which sentences are false. What logic helps us do is figure out which sentences can be, when put into a set, are consistent with one another. But we can also figure out which sentences are what's called logically true. So we can't figure out whether or not a sentence is in fact true, but we can figure out if it is logically true. So what do we mean by this? Well, some sentences, in virtue of their form, will just always be true. So let me write this down. So first, let's make this point that I just made. So logic does not help us figure out which sentences are true, but can help us. So logic can help us figure out which sentences are, and I'm going to put this in caps, logically true. And so here's what we mean by logically true. Or sorry, let me give you the example first that I said. So either it is raining outside or it is not. So let that be our whole sentence. This sentence will always be true, because suppose it's raining outside, then this sentence is true. Why? Because it says either it is raining outside or it is not. And it is in fact raining outside, so this sentence is true. Now consider the scenario where it is not raining outside. Well, the sentence is still true. Why? Well, because either it is raining outside or it is not. And we just said that it's not raining outside. So that means that we've satisfied this part of the sentence. So in either scenario, whether or not it's raining outside, this sentence is always true. And the reason why it's always true has to do with its actual form. So this sentence is always true in virtue of its form. And that's what we mean by logical truth. So we'll say that it is so let's give a formal definition then of logical truth. Say logical truth by definition is a property of a sentence. So notice the difference here. Before we had consistency, and consistency is a property of sets of sentences. Logical truth is going to be a property of a sentence, not sets of sentences. So logical truth is a property of sentences. So by definition then we say that a sentence, not a set of sentences, but a sentence is logically true if and only if it is not possible for the sentence to be false. So up here we had an example where the sentence, it's not possible for the sentence ever to be false, right? Either it's raining outside or it's not. And in the scenario where it is raining outside, the sentence is true. And in the scenario where it's not raining outside, that sentence is true. So it's not possible for the sentence to be false. Okay, so where we now have a concept of logical truth, we can also talk about logical falsity. Logical falsity. And this is going to look very similar to logical truth. We're just going to do the opposite. So, and remember, this is a property that is going to apply to a sentence. So we say a sentence, not a set of sentences, but a sentence is logically false if and only if it is not possible for the sentence to be true. So let's give an example. We can use the one that we had beforehand. So it is both raining outside and not raining outside. This sentence is logically false. Why? Well, because suppose it's raining outside. Then the first part of the sentence where we say it is raining outside is true. But the sentence isn't just saying that. It is saying it is both raining outside and not raining outside. But outside, if it's raining, it can't be not raining, right? It's one or the other. So this sentence can't be true then, because it's saying that both things are happening at the same time, but it can't. So in the scenario where, for example, it's not raining outside, then the sentence, this part of the sentence will be true, namely that it is not raining outside. But the sentence is also saying that it is raining outside, but we just said that it's not raining outside. So this sentence can't actually ever be true, right? It is always false. And the reason why it's false has nothing to do with its actual content, right? We could put anything in here we like. Instead of raining outside, we could say, is snowing outside, or it is both the case that I am hungry and not hungry, for example. So you can swap out raining outside with another sentence, whatever other sentence you like. But the sentence will always be logically false. Why? Because it's in virtue of the form. So this sentence is, and we'll say logically false to distinguish it from being false. So when something is logically false or logically true, what we mean is the sentence is true or false with respect to its form, not with respect to what it's actually saying or the content of it. So this sentence is logically false in virtue of its form because it is not possible for the sentence to be true. In every scenario you can imagine, this sentence will always come out false. Okay, and there's a third related concept here, which we call indeterminacy. So some sentences will be logically true, some sentences will be logically false, but some sentences might not be either. So if I had, let me put this, and this is going to be called logical indeterminacy, or they're going to be logically indeterminate. Logically indeterminate. Okay, so let me give an example first. Bert is Canadian, and it is raining outside. This sentence is logically indeterminate, right? The sentence might be true or it might be false, but it is neither logically true nor logically false. In other words, there's nothing about the form of the sentence that makes it true or false. All we know is that the form of the sentence isn't of the kind where it has to be logically true or it's logically false. So let's give a definition then of logical indeterminacy. So again, this is a property of a sentence, not a set of sentences. So a sentence is logically indeterminate if and only if it is neither logically true nor logically false. So whenever a sentence is neither logically true nor logically false, then we say that the sentence is logically indeterminate. Okay, and we have one more concept to cover, which is called logical equivalence. So let me move this up a little bit. Okay, so some sentences will be the same with respect to their form. So, for example, here's two sentences that are not logically equivalent. Are not logically equivalent. Bob loves Sally. Sally loves Bob. These sentences are not logically equivalent. Why? Well, because they're saying different things. Right? I mean, Bob loving Sally does not imply that Sally then also loves Bob. Poor Bob. But some sentences are actually going to be logically equivalent. And the way we do that is by saying that basically whenever one sentence is true, the other sentence will be true as well. And whenever the other one sentence is false, the other sentence will be false as well. In other words, they'll always be true at the exact same time, or they'll always be false at the exact same time. So we'll do equivalence. Here's our definition. A pair of sentences. So for now, we'll define it just as a pair, but it doesn't actually just have to be a pair of sentences. It could be more, but the idea here is that you need more than one. So we'll say a pair of sentences because, sorry, let's do this properly. So, actually no, let me just do it like this, intuitively. So we'll say a pair of sentences. I'm struggling with the grammatical part here. So, pair, the members, let's do it like this. The members of a pair of sentences are logically equivalent if and only if it is not possible for one of the sentences to be true while the other. So here's an example. Let's do this. Snow is white. Take that as one sentence. Schnee ist weiß. These sentences are logically equivalent. One of them is in English, and it says that snow is white, and the other one is in German, and it also says that snow is white. These sentences are logically equivalent. That is, whenever the sentence snow is white is true, it will also be the case that Schnee ist weiß is true. And vice versa. Whenever this sentence is true, that Schnee ist weiß, snow is white, will also be true. So that's our notion of logical equivalence. Whenever you have more than one sentence, whenever they're true in the exact same scenarios, then we say that those two sentences are logically equivalent. Okay, so this section was a little bit longer. Thanks for hanging in there. If you have any questions, again, make sure to bring them to class, and we'll talk soon.